All right, we've hit our open-ended problem. Simplify the expression x squared minus 3x minus 28 all over x minus 7. Write the expression in its simplest form as a polynomial expression. So what I'm going to want to do is factor that guy up there. I need two numbers that add up to -3 and multiply out to 28, and I'm going to write it out like this. If they're going to multiply out to a negative, one of them is going to be positive and one of them is going to be negative. So thinking of numbers that subtract out to 3, 7 and 3 would have me multiply out to 28 and subtract out to a 3. Now which one gets the negative, the 7 or the 3? Well, since this is -3, the larger number is going to get the 7. So you have x plus 3, x minus 7, all over x minus 7. Now the entire denominator is a group. So since I have this times that over that, and these two that's are the same, I can cross those things out, leaving me with x plus 3. And that's going to be my expression. So part A is me factoring that out, crossing out something over itself, and being left with x plus 3. Let's take a look at part B. What is the least common multiple of 6x squared y cubed and 10x cubed y? Well, let's figure out all the multiples that give me 6 and 10. And I kind of have it in my head, but let's do this one step at a time. So let's do 6 could be 6, 12, 18, what else? 24, 30, 36. Let's take a break. Okay, all the common multiples of x squared could be x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, and y cubed could be y cubed, y to the 6th, y to the 9th, y to the 12th, and we'll take a break after that. Let's focus now on the 10. The 10 could be 10, 20, 30, 40, so I hit my number, I see it already. X to the 3rd could be x to the 3rd, x to the 6th, x to the 9th, x to the 12th. And y could be y, y squared, y to the 3rd, y to the 4th, blah, 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 blah. So let's look at the numbers. 30, 30, match up. X squared, nope. X to the 4th, nope. X to the 6th, yup. That's my least common multiple. So y to the 3rd, y to the 3rd, yup, y to the 3rd. Tricky stuff. Least common multiple. List out all of your multiples and then circle the smallest of them all, because that's what least common multiple means. Now we're at greatest common factor. So what you're doing with greatest common factor is similar, but you're writing all the numbers that could possibly multiply out to 12 and 2. So 12 could be 1, 2, 3, 4, 6, and 12. X cubed could be x, x squared, x to the 3rd, and y to the 5th could be y, y squared, y cubed, y to the 4th, and y to the 5th. Okay? Let's do the same thing with 2. 2 can just be 1 and 2. X squared is just going to be x and x squared, and y to the 7th is just going to be y, y squared, y to the 3rd, y to the 4th, y to the 5th, y to the 6th, y to the 7th. Now we're going to circle the greatest of these. So over here it's simple, it's just 2. Okay, so not that pretty. The greatest x value in common is going to be x squared, and the greatest y value in common is going to be y to the 5th. Now, this is where things get a little wacky. It says that the expression x squared minus bx minus c all over b, or x plus b, simplifies to x minus 6. What that means is x squared minus bx minus c over x plus b equals x minus 6. Now, this is a really crazy problem, and this is how I'm going to handle it. I'm going to multiply both sides by x plus b. All right? I'm going to multiply both sides by x plus b, and what that does is that allows us to get rid of u, leaving me with x squared minus bx minus c. That's going to equal a FOIL problem, so let's FOIL it out. Okay, we have x times x is x squared. We have x times x, or b, which is going to be bx. We have negative 6 times x, which is negative 6x. And we have negative 6 times b, which is negative 6b. Right? So what happens is we really can't combine a whole lot except for the fact that these guys will cross out. Now my job is to find b, so what I want to do is get all the b's to one side of the equal sign. Actually, let's do this instead. Let's just match things up, okay? Because you guys are supposed to be the same as you guys. So let's just set negative bx equal to bx minus 6x and solve for b that way. Now they all have x's in common, which means we can get rid of the x's. So negative b equals b minus 6. Subtract b, let's put it up here. That gets you negative 2b equals negative 6. Divide by negative 2, divide by negative 2, and b is going to equal 3. That was a very, 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 very difficult problem. I didn't like it. Not at all.